Everybody, today's topic is two-step equations. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Remember that you can also pause the video to jot down important notes, rewind the video to view information again, and fast forward if you think you got it. Just be careful and make sure you don't miss out on anything important. Alright, so we're going to first talk about the steps to solving two-step equations. And it's going to be weird, but I'm first going to talk about putting on your shoes and socks. So the steps to take off your shoes and socks are very similar to the steps to solving two-step equations. And you'll find out soon what I mean. So the first step, and you're going to want to write this down, to taking off your shoes and socks is to first find your foot. And then you want to figure out all the operations that your foot went through to be bundled up in your socks and your shoes. And then when you want to take off your shoes and socks, you will need to undo those operations and go in reverse order. So the steps to solving a two-step equation is very similar. The first step is to find the variable. This should say 1, 2, and 3. Is to find the variable and then figure out all the operations that the variable went through, just like how you're figuring out all the operations your foot went through. And then the third step is to undo those operations and go in reverse order. So we're going to go over some examples of what we mean by that, but make sure that you pause the video and write down these steps before we go on. Okay, so as a review, when you're trying to take off your shoes and socks, you first have to find your foot. And look, your foot is underneath the shoes and the socks. Then you need to figure out all the operations that your foot went through. Okay, in the morning, I put on my socks first, and then I put on my shoes. Put on my shoes. So if I wanted to undo those operations and go in reverse order, I'm going to take off my shoes first. That was the last thing that happened. I need to do the reverse. Instead of putting on my shoes, I'm going to take off my shoes. That was the second thing that happened. So now it's going to be the first thing that we're going to do in order to undo what happened. Okay? So everything is reversed. Step 1 becomes step 2. Step 2 becomes step 1. Putting on becomes taking off, and putting on becomes taking off. So when I go home, I need to take off my shoes first, because that was the last thing that happened, and then I need to take off my socks, okay? So everything is going in reverse. Like, you wouldn't be able to take off your socks first and then take off your shoes, right? You have to go in that reverse order. So, similarly, for a problem, like a two-step problem, you're going to have to do the same thing. In this problem that you're going to write down in your notebook, 3p plus 1 equals 10, we first have to find the variable. The variable is usually a letter, but it can be any kind of symbol that's representing an unknown amount. And in this case, and in algebra, it's usually a letter. So in this case, the variable is p. So we found the variable. It's right there. The variable is p. Then we had to pretend like P is the foot that got up in the morning and put on its socks and shoes. So we have to retrace what's going on. What's the first thing that P is attached to? Most people would say plus 1, but it's actually literally attached to this 3. And there is no operation sign next to it, but it's actually multiplication because there's an invisible multiplication sign right there. So the first operation that it went through was it got multiplied by 3. Okay, again, a lot of people think that it's adding, but it's literally attached to that 3 through multiplication. So the first step it went through was it got multiplied by 3. And then after it got attached to that 3, it got added to 1. So if we wanted to go in reverse, we are going to treat that add 1 like the shoes. We have to unravel that first. The opposite operation to adding 1 is subtracting 1. So that needs to happen first. And then we are going to divide by 3 because that's the opposite of multiplying by 3. So everything is going in this reverse order now, okay? Get the opposite of adding 1 first, which is subtracting 1, and then the opposite of multiplying by 3, which is dividing by 3. That's how we came up with these reverse operations or inverse operations. Then here I'm showing you how we're going to do that. If we subtract 1, then we can get rid of this 1. So plus 1 and subtract 1. It's kind of like taking one step forward and taking one step back. It kind of negates it. It cancels it out. So this gets canceled out. We have to do the same thing on both sides. So that's why I have minus 1 equals minus 1. So we're looking at the equal sign as if it's a fence. If I do one thing on one side of the fence, I have to do the same thing on the other side of the fence. It's like neighbors who want to have things fair, right? So subtracting 1 on the left-hand side is going to get rid of the adding 1. And then on the right-hand side of the fence, it's just going to become 10 minus 1, which is 9. So now you are left with 3p on the left-hand side because the 1's subtracted and got rid of it. And then you're left with 9 on the right-hand side because it also subtracted 1. Then remember that 3 was being multiplied by the p, so you're going to need to divide by 3 to get rid of it. Same thing on the right-hand side. 3 divided by 3 is 1. Anything divided by itself is 1. So that's how we end up with 1p on one hand. And then we have 9 divided by 3, which is 3 on the other hand. So it looks like your answer is 3. You always want to check your answer. If I were to put 3 back into the problem, instead of 3 times p plus 1 equals 10, it would be 3 times 3 plus 1 equals 10. 3 times 3 is 9. 9 plus 1 does equal to 10. So that is correct. It's always a good idea to plug your answer back into the problem to double check, because there's always a chance that you're going to plug it back in and then you're going to be like, wait, that's not the answer. I did something wrong up here, okay? So just because you got the an answer doesn't mean it's the answer. So that's one example of solving two-step equations. Make sure that is in your notebook. We're going to go through a different type of example next. All right, in this problem, we have m minus 73 divided by negative 7 equals negative 2. Okay, so we're going to go through the same motions. We're going to find the variable. It's m, and it's right here. Locating the variable is a great first step. Then we're going to look at what happened to m first. Okay, what is directly attached to m? It's not dividing by negative 7. It is the closest thing that's happening is it actually subtracted 73 first. And then we took that entire answer and then divided it by negative 7. I know that the division is second because it took the answer of the previous operation and then divided it. That division bar is long. It includes the subtraction problem. So that tells me that it was the second thing that actually happened. Okay? So the first operation was subtract 73, and then we divided that whole thing by negative 7. So those are our first two steps. So to work on it in reverse, we're going to start with the last step, it divided by negative 7. So our first step, our taking off of our shoes, is going to be multiply by negative 7. The reverse of division is multiplication. And then our second step will be to reverse the first thing that happened. So the opposite of subtraction is addition. So we're going to undo that by adding 73. So we're going to do that here. First step is to, like we said, multiply by negative 7. When I multiply by negative 7, I have a negative 7 on top and a negative 7 on the bottom. So that's like negative 7 divided by negative 7, which cancels itself out and becomes 1, okay? So that's how we're left with m minus 73 on the left-hand side. If we do the same thing on the right-hand side of the equal sign to make sure that we are treating our neighbors fairly, then we have negative 2 times negative 7, which becomes a positive 14. Two negatives cancel and become positive. Then we have our last step, which is adding 73 to both sides of our neighbor's fence. That cancels on the left-hand side, taking 73 steps back and then taking 73 steps further ahead is going to be like you did nothing at all. And then on the right-hand side, 14 plus 73 is 87. So we end up with m equals 87. We're going to check it by putting it back into the equation. Instead of m minus 73 divided by negative 7, we're going to put 87 minus 73 divided by negative 7. 87 minus 73 is 14. 14 divided by negative 7 is indeed negative 2. So that is our correct answer. Okay? We're going to go through one last example. It's a different type of example, so make sure that all three of these examples are in your notebook. It's a lot, but these are the three most common types of examples, so it's important to have it in your notebook as a reference for you when you encounter these types of problems. So for this third example, we have the problem 3 equals f divided by 6, f over 6, that's a division bar, so it's divide, minus 1. We're finding the variable first, it's f. And then remember, the point of finding the variable first is to then locate its operations. So here, f is first attached to the 6 through division, okay? Very different from the previous example. The previous example also had a division bar, but it was over the entire subtraction problem. So that told us that the subtraction happened first. Here, the division is a smaller division because it's only dividing f. So we know that that one happened first. F divided by 6 first and then subtracted 1. It's the opposite of what we had in the previous example. Why am I giving you the complete opposite? Because people mix them up sometimes, okay? So the reverse, we're going to work in the opposite direction. We're going to work on the subtract 1 first by doing the opposite. So we're adding 1, and then we're going to unravel or undo the divide by 6 by multiplying by 6. So we're going to add first and then multiply. We're going to add 1 to both sides of the fence. Minus 1 and add 1 is going to cancel each other out. That's like taking 1 step back and then 1 step forward. You're back to where you were. So that's gone. And then we end up with 4 on the left-hand side. So we end up with 4 equals f divided by 6. So that was adding 1. Then we're going to multiply by 6 both sides. 4 times 6 is 24 on the left-hand side. And then the 6 on top and the 6 on the bottom is like 6 divided by 6, which is 1. So it's 1f. So our answer is f equals 24, or 24 equals f, same thing. If I were to check it, I'm going to put that 24 back into the problem where I saw f. So it becomes 3 equals 24 divided by 6 equals 1. 24 divided by 6 is 4. 4 minus 1 is 3. So that answer is correct. Okay? Let's do one example on IXL just so you can practice. So here's a problem. It says solve for z. 3z minus 2 equals 4. Go ahead and pause the video and try it on your own first. All right, so I'm going to locate the variable. It is here. It is the z. And I'm going to write my z's like this because I don't want it to be messed up with my 2's. Okay, so I have that z. I need to first figure out the operation. It is attached to that 3 with multiplication. So it multiplied by 3 first. And then the second step was it subtracted 2. So going in reverse, I'm going to first have to add 2. And then I'm going to divide by 3. So I'm going to take my 3z minus 2 equals 4. First step is add 2 to both sides. So I end up with 3z equals 4 plus 2 is 6 because this canceled out. The minus and the plus cancels each other out. So I'm trying to simplify it more and more so I end up with just z as my answer. My next step is to divide by 3. I know 3 divided by 3 is going to be just z, so z equals 6 divided by 3, which is 2. So my answer is 2. Z equals 2. I might want to check it first, so let me check it by putting it back into the problem. 3 times z becomes 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2 is equal to 4. Yes, so it's correct. I'm going to have to clear this so that, so that I can put in my answer. All right. Okay, so it's going to get progressively more and more difficult, so make sure that you do have those 3 examples written down in your notebook so that you have them as a guide. Let me know if you have any questions as you work on these problems. I'll be more than happy to answer them. And if not, I will see you in class.